All right, we're going to create a special stack that has a GetMin function that will return the minimum element in that stack in O of 1 time and O of 1 space. So let's go ahead and go through a quick little example. Say we've got 3, 5, 2, 1, 1, and -1. So ultimately, if we were to push this entire, all of these numbers into a stack, then our minimum element would be -1 that we would want to return. So to do this, we're going to kind of encode the minimum elements as we find them, so that as we're popping them or peeking at them, we can see what the previous minimum element was and keep track of them that way. And to do this, we will use two formulas when we're pushing. We're going to use 2 times x minus the minimum element, and that will be stored on the stack, and then we'll have a variable minimum element that will store the real minimum element. And then to pop, let's see, this is for push, and then when we pop, we're going to go ahead and return 2 times, or we're going to go ahead and use 2 times the minimum element minus x to calculate what the previous minimum element was. All right, so first we'll go ahead and create our stack. So we've got special stack, and in that we have a stack, and this is, we're going to use ints in this example. Special stack. Okay, and then we're also going to need to store the minimum element. The current minimum element, I should say. Okay, and then we've got our push function we'll do first. So and that's going to take in an int. Okay, so first thing we want to do is check to see if the stack is empty, because that'll be our first element that we're putting in, which would mean that it would automatically become the minimum element. So if special stack dot count is equal to 0, then we know that we want to go ahead and store that minimum element equal to data. Okay, and then we can go ahead and put in our checks for actually pushing these things into the stack. So if the data is greater than or equal to the minimum element, then we want to go ahead and just push it to the stack. And if the data is less than the minimum element, then we know we have a new minimum element, and we will want to encode that. So push. Okay, and the encoding again is 2 times data minus the min L. Okay, and then we need to make the minimum element equal to the actual data so that we've got that Okay, and then that should work for push. And then we just need to have a pop function so that it checks to see if something's the minimum element before or while it's popping. And it's going to return the popped element. Okay, so we'll go ahead and store the popped elements in this variable so that we can do things with it and keep track of it. So if data is less than the minimum element, that's when we know we have that's when we know that it is a minimum element. So we'll keep track of the real value, and that's going to equal the minimum element that we're currently storing. And then we want to decode to get the previous minimum element. So then min element's going to become, it's going to become 2 times min L minus data. And then we've got, we're just going to return the real value. So that is if we have, that's if it was a minimum element. So now we have stored the new minimum element, which was the previous one that had loaded before this one we just popped, into the minimum element variable. If it doesn't, if the data is greater than minimum element, then we're just going to return data because it means it wasn't a minimum. So there's our pop. And then we can go ahead and write our GetMin function. And all that's going to do is return the minimum element, because that will always be current with whatever minimum element is in our stack. And it will do it in of one time because it is just a variable that we're just accessing. And then we can also make a peek function, because that peek is going to work differently as well, because we need to also test to see if it's a minimum element and then convert it over, or send the minimum element instead of the encoded element. If ss.peek is less than the minimum element, then we know that it is the minimum element, which means we would return min L. Otherwise, we can just do a regular peek. And that should take care of it. So let's go ahead and test this out. We can use our original data set, try to get this size that we can see. Okay, so we want to keep track of, we'll first push everything in, and so we'll keep track of, let's go ahead and make this easier to see. So we'll keep track of our push and min L to start. Okay, so the first number that we are looking at is this 3. So if we push the 3 in, our special stack count, let's go ahead and, well, in the push, that'll be our stack. Okay, so our count is 0, so min element is going to equal data, so min element is 3. And then if data is greater than or equal to the minimum element, we would push the data, and 3 is greater than or equal to 3, so we can push our 3. I'm just going to push from the bottom here. And then that is all we need to do there. So if we want to push our 5, then we come in, and 5 is greater than or equal to our minimum element of 3, so we can just put the 5 there. And then we go to the 2, and the 2 is less than minimum element, that's 3. So we're going to push 2 times data, so 2 times 2 minus 3 is 1. So we're going to push 1, and then minimum element is going to become 2. Okay, and then if we push the 1, 1 is less than our minimum element of 2. So 2 times 1 is 2, minus 2 is 0, and then minimum element becomes 1. We push this other 1, it's equal to the minimum element, so we just push the 1. And then when we get to -1, it is less than the minimum element, so we do 2 times -1 is -2, minus 1 is -3. So -3 is pushed to the stack, and we store the -1 in minimum element. Okay, and that completes our example, so then we can go into pop. So we go in and we can go ahead and store, I think what makes sense would be to say we've got our pop here, but we're really going to want to have, I want to keep track of the real numbers and the kind of start numbers, because some of them will be a little different. So I'll just kind of put those on top just to kind of look at them. So when we go in, data is going to equal the pop. So that's what we could do. This is kind of data. All right, so data is ss.pop. So the first thing in our stack to pop is the -3. And we look at this, and if -3 is less than the minimum element, which it is, -3 is less than -1, then real value equals the minimum element. So our real value is -1. Minimum element equals 2 times minimum element minus data. So 2 times -1 is -2, minus data is -3 here. So -2 minus -3 is +1. So that is what minimum element becomes, is back to +1. And then we're returning real value, which is this -1. Okay, so then we go through, and if we want to, and now this has been popped. Okay, so then if we go back to our stack, we've got 1 is the top, so we pop that off. Data equals 1. 1 is not less than the minimum element of 1, so we go ahead and return 1, and that's what's going to be popped there for the real numbers, and 1 has been popped off. So then we go in, and 0 turns into data, so data is 0, and then we go in. 0 is less than 1, so we know we have a minimum element. So we go in and we say real value equals minimum element of 1. Then the minimum element is going to equal 2 times 0, which is 0. No, sorry, it's going to be 2 times 1, which is 2, and then 2 minus 0 is 2. So minimum element becomes 2, and then we return the real value, and we had to put the 1 there. So then we go back in, and this has been popped off, and we look at the next number, 1. And so is 1 less than the minimum element? Yes, it is. So we have data is 1. Then we say minimum element, or we should say real value equals minimum element, which is 2. Then minimum element is going to equal 2 times minimum element, which is 2. So 2 times 2 is 4, minus 1 equals 3. So now minimum element becomes 3, and we return the real value of 2. All right, and then we go in and 1 has been popped off. And now we go in and we've got a 5. Is 5 less than the minimum element? No, it's not. So we go ahead and put that in real, return that into our real numbers. And then we go in, 5's been popped off, and we say, okay, we've got 3. Is 3 less than the minimum element? No, it's not. So we go ahead, and 3 was data, and we return data. So that looks to be about right because we started with 3, 5, 2, 1, 1, and -1 in our original numbers that we pushed. And we managed to pop all of those off correctly in the correct order, as in last in, first out. So that totally works. If we wanted to get the minimum right now, it would return 3. And since I should say, if we got the minimum before we eliminated this last piece, it would return 3. So maybe we want to add a little line in that if we're popping that last number off, we need to kind of delete it out of the min element. So we could probably put a little statement in there of let's see. I think we could do it in here. We'll just kind of add a little if, let's see, if SS.count equals 0. So if we're on our last, we've already popped off that last element. So if the count equals 0 at this point, then we would want to set minimum element to be null so that it doesn't contain that 3 just sitting in there. So that'll take care of that little bug. And then if we're going to peek, that should work just the same as kind of the pop where we're just checking to see if something's the minimum element or not, and we're just returning that minimum element. So that should be just fine. This is going to work again in O of 1 time and O of 1 space for the GetMin function. Because we are not using any additional data structures. And we are able to just return it in a constant time. The push would be O of n, and the pop would be O of 1. All right, so that should take care of that.